In this session we shall see the analysis and design of Extradosed Bridge for PSC Box Girder superstructure, substructures, foundations, bearings, and drawings. The Astra Pro main screen is opened, select Menu Item File, then select Working Folder. As the selection box comes, user may use the button Browse and select Folder Work on the desktop. Next, select Menu Item File, then select Bridge Design and further select Extradosed Cable Stayed Bridge, then Bridge on Towers on either side, then IRC/IS Standard. As the window opens with 3 spans, with central or intermediate spans of length 100 meters and either side or end span of length 65 meters, thus making the total length as 230 meters. The various analyses data are given as default. The various tab pages of the window for various details are for individual tasks related to the analyses of the grillage model of the bridge superstructure. The design job number is 1. Click on button New Design. Message comes as the project is created as design job number is 1. Crash barrier is considered on left side only, with no raised footpath. In the page for cross-section details, in this tab page there are 2 pages. The tab page data inputs take the data of various elements of the cross-section as user inputs, at the various dimensions of the girders at various sections are displayed. In page results of section properties, click on button Show Results. The calculated values are displayed. The calculation details are also shown in the page. As the box girder is modeled as coplanar grillage model, some default percentages of the total actual box girder section properties are assigned to long members of the model. In the page for moving load data, the various combinations of Class A and 70R wheel loading are applied lane-wise on the bridge deck on the left panel. And the various load types are defined on the right panel, referring to IRC 6. By clicking on button View Moving Load, user may see the animated view of moving of vehicle axles over the bridge deck. After viewing, close the view window. Next, we open the tab page for Analysis Normal Process. In the page Analysis Normal Process, the end supports and material properties for PSC Box Girder are mentioned. Click on button Create Analysis Data. Next, process all the analyses input data are created. By selecting an analysis for a particular dead load or moving load applied lane-wise, the user can see the related analysis input data file and the live load as moving load types in file lol.txt. Close these files. Next, click on button Process Analysis. The list of all 8 processes are displayed. Click on button Process to start the process. As the process starts, the dialog box comes to verify the analyses data. Click on button Proceed. As the data check is over and load cases are obtained, the message comes. Click on button OK. Next, the dialog box comes to process the analysis input data. Click on button Proceed. The analysis will be done and the message comes informing that the report is created. Click on button OK. This completes the first process of total 7 processes. The other processes in the list are all processed one by one, and finally the reports of all the 8 analyses are read to get the maximum member forces at various points of the bridge superstructure and maximum reaction forces at the supports required for the design of bearings, abutments, and piers. By selecting a particular analysis, user may open the respective analysis report. Hence the basic main analysis is over. Next, open the page for stage analysis, where analysis for all 8 processes will be done for 5 stages. In each stage the deflections of each node of the model are added to the last coordinates of the structure, and then the loads are applied and the structure is reanalyzed to get the forces as result of nonlinear analysis. The page for stage 1 is opened. Click on button to create analyses data for all the 8 processes. Like basic analysis, all the 8 analyses are done one after another, and finally the maximum member forces and support reactions are obtained for the stage 1. Next, the page for stage 2 is opened. Click on button to create analyses data for all the 8 processes. Like basic analysis, all the 8 analyses are done one after another, and finally the maximum member forces and support reactions are obtained for the stage 2. Next, the page for stage 3 is opened. Click on button to create analyses data for all the 8 processes. Like basic analysis, all the 8 analyses are done one after another, and finally the maximum member forces and support reactions are obtained for the stage 3. Next, the page for stage 4 is opened. Click on button to create analyses data for all the 8 processes. Like basic analysis, all the 8 analyses are done one after another, and finally the maximum member forces and support reactions are obtained for the stage 4. Next, the page for stage 5 is opened. Click on button to create analyses data for all the 8 processes. Like basic analysis, all the 8 analyses are done one after another, and finally the maximum member forces and support reactions are obtained for the stage 5. Next, the page for design forces is opened. Select a particular analysis for its maximum member forces and support reactions, which shall be used for the design of structural members of the bridge superstructure, substructure, bearings, and foundations. Next, the page for design of bridge superstructure is opened. There are other tab pages: bridge deck design, cable structure design, and alternative design in text format. Under tab page bridge deck design there are tab pages PSC Box Girder, cable friction, temperature stresses, cross diaphragms, end anchorage, blister block, structural design. Currently, the tab page for bridge deck design and further tab page PSC Box Girder. There are tab pages for general input, section properties, bending moment, shear force, pre-stress, and temperature. All these tab pages take input for the design of PSC Box Girder. Default values are given for each data input, which user may change as desired. Only the values for bending moment and shear forces are taken from analysis selected under Design Forces. Click on button Process for new design. As the worksheet opens, the various tabs at the bottom of the worksheet may be opened to check various steps of the design. Next, the page for cable friction is opened. Click on button Process for new design. The worksheet opens with various inputs as default values in the Excel worksheet, which user may change as desired. The various tabs at the bottom of the worksheet may be opened to check various steps of the design. Next, the page for temperature stresses is opened. Click on button Process for new design. The worksheet opens with various inputs as default values in the Excel worksheet, which user may change as desired. The various tabs at the bottom of the worksheet may be opened to check various steps of the design. Next, the page for cross diaphragms is opened. Click on button Process for new design. The worksheet opens with various inputs as default values in the Excel worksheet, which user may change as desired. The various tabs at the bottom of the worksheet may be opened to check various steps of the design. Next, the page for structural design is opened. Click on button Process for new design. The worksheet opens with various inputs as default values in the Excel worksheet, which user may change as desired. The various tabs at the bottom of the worksheet may be opened to check various steps of the design. Next, the page for cable structure design is opened. Click on button Read Data. This creates the data as read from the model defined for analysis at the beginning of this session. Next, click on button Process. This will open the detailed design report. Next, the page for RCC abutment is opened. The two options available are for abutment with open foundation and abutment with pile foundation. We select the option abutment with pile foundation. Click on button Process for new design. The Excel worksheet opens. There are various tab pages at the bottom for various design aspects and may be checked and finally closed by the user. Next, the page for RCC Pier is opened. The two available options are for Pier with open foundation and Pier with pile foundation. We select the option Pier with pile foundation. Click on button Process for new design. The Excel worksheet opens. There are various tab pages at the bottom for various design aspects and may be checked and finally closed by the user. Next, the page for drawing is opened. Upon selecting the desired button, the set of sample drawings are opened in Astra Viewer CAD for necessary editing and saving either as DWG or DXF file. Upon finishing, user may close the CAD window. This is the end of the session for the design of Extradosed Cable Stayed Bridge. You may write to techsoftinfra@gmail.com or techsoft@consultant.com. Thank you.